Yeah, hello everyone. In the last video, we tried to understand the operations and signals. Uh, Examples, we try to understand only operations on dependent variables. Uh, and let us try to understand in this particular video what are the different types of operations we have on independent variables and with an examples. And I'll be asking you to sketch some signals, based on the understanding of these independent operations. So operations and independent variables, like uh, operations and independent variables, operations on independent variables. What are the operations we have seen on independent variables? There are in the previous video we have seen three operations. One is time folding operation. Second is time shifting. Third is time scaling. And we also seen the scaling operation in the dependent variables, that is considered as amplitude scaling, and here we try to focus on uh, time scaling. So I'll be explaining you what exactly the difference between the amplitude scaling and time scaling at the end of this particular session. Now let us try to understand what is exactly mean by time folding operation. What is exactly mean by time folding? Suppose if I say time folding or time reflection, we call it as time folding or time reflection, we call it as. Let us consider a signal x of t. And if I say x of minus t, this x of minus t is the time folded version of this x of t, and this x of minus t and x of t are known as mirror images of each other. So what we have to do, just in order to sketch this x of minus t, we have to fold a given signal with respect to vertical axis. So example, if I say, if I try to sketch x of, suppose example, say it as x of t, signal like this. This is the 10, amplitude is 10, and this is 0, and this is t. Now I want to sketch the time folded version of this x of t. This is the x of t. How do you sketch? So this is a simple example. Just what you do is like just fold this particular signal. When I say in order to sketch this x of minus t, fold this particular signal with respect to vertical axis. Just you try to fold the signal with respect to vertical axis, it looks like this. So time folded version when I say. So simply we can note down this x of minus t as a signal like this. Just you try to fold this particular signal with respect to vertical axis. So it looks like this. Without changing the amplitude, this will be 10 and this will be t and this will be 0. So now these two are mirror images. The reason why we are calling these particular signals as mirror images of each other, if you try to place a mirror here, from 0 to infinite, whatever it is there here from 0 to infinite, that reflects in the mirror. And same thing, the reflection is nothing but this particular signal. So that's the reason this operation is also known as time folding or time reflection operation, we call it as. And this x of minus t and x of t are known as mirror images of each other. Now I'll try to give you another example. I expect you to sketch this particular signal. Suppose if I say x of t is a signal, this is my signal as a ramp function, and just think about it, how to sketch this particular, this is t, how to sketch x of minus t for this particular signal. So now this is the time where you have to reflect yourself and try to sketch x of minus t for this based on this. As I mentioned very clearly, just place a mirror at this vertical axis and try to see what is reflecting in the mirror and try to accordingly. I hope it is done. You can cross check your you can cross check your answer with this. As again, if I try to place a mirror here, just try to fold a signal with respect to vertical axis. So it looks like x of minus t will be a signal like this. So this is signal. So these are two mirror images of each other. Just if I try to place a mirror here, the same thing reflects. Just try to fold the signal with respect to vertical axis. This is the way how a time folding operation can be performed on the signals. This is valid. Very simple signals I have taken to explain you to sketch x of minus t if x of t is given. Similarly, even we can take any signal and we can try to sketch the signals accordingly. Now, let us also try to understand how what are the other operations. Time shifting. When I say time shifting operation, say it as x of t is a given signal, and now x of t minus t naught, or x of t plus t naught, or also write x of t plus or minus. So when this t naught is a constant, the amount of shift constant, the amount of shift we are trying to shift the signal. So this is x of t is a given arbitrary signal, and this is a delayed version of x of t. This is considered as delayed version of x of t, and this is called the advanced version. This is called advanced version of x of t. So let us try to understand how this delayed versions can be sketched and how advanced versions can be sketched. And the t, when I say t is a constant, that is the amount of shift we are trying to shift this particular signal. So simple, just you try to, when I say this minus represents advance, minus represents delay, delay means always right shift the signal, and when I say this plus means advance means always left shift. If you remember this, it will be easy for us to sketch the delayed and advanced version of the given signals. So it's very clearly mentioned here. If I want to sketch delayed version or advanced version, minus represents delay, plus represents advance, minus represents delay, plus represents advance. When I say delay means the signal will be shifted towards right side. When I say advance means the signal will be shifted towards left side on the time axis. So example I try to explain you, I may ask you to sketch similarly for the different signals. So when I say example for this, which will make you to understand how this particular delayed and advanced versions can be sketched. Example simple, I'll say it as u of t. Very simple example, I'll say u of t is this is my signal u of t, and this is 0. Now if I want to understand how u of t minus 15 can be sketched, u of t minus 15 I need to sketch. As I mentioned, when I say u of t minus 15, if I want to sketch this u of t minus 15, minus represents always delay means right shift. So how much we have to shift, how much amount of time we have to shift towards right side? 15. So rather than starting the signal, the same signal will move towards right side by an amount of 15. So this is 0. So it starts at 15 and continues up to minus infinite with an amplitude of 1. So this is the way how the delayed version of the signal can be sketched. If I want to sketch u of t plus 15, if I want to sketch u of t plus 15, so plus means already I told you it's an advance in the sense left shift by 15 units. So it looks like this. Rather than starting at origin, this signal will be shifted towards left side. Signal will be shifted towards left side. So it starts at -15, starts at -15, and it continues. This is 1, this is 0. This is the way how the delayed version and so this is the amount of time, this is the amount of time we call it as delay. This is an amount of time we call it as delay. And this is an amount of time which we call it as an advance. This is an amount of time we call it as advance. It is advanced by 15 seconds, whereas this is advanced by 15, delayed by 15 seconds. So if you look at on the time axis, if you look at on the time axis, so when I say if it is look at on the time axis, this is my 0, minus infinite to plus infinite, minus infinite to plus infinite. Instead of happening the things at origin, if the things are happening at 15, means what is happening? The things are being delayed by 15 seconds. That is the meaning. That's the reason when I say delayed, means delayed by 15 seconds. Suppose the class supposed to start at origin at 0 or at 9, but due to various reasons it has not started on that particular time. It has been delayed by 15 minutes means. So we try to move on the time axis. We try to move on this particular time axis towards right side. That's the reason. Delay means right shift. Similarly, if the class starts at least 15 minutes before the commencement of the class, in that case, the class starts somewhere -15. We have preponed, advanced the class and started 15 minutes before. That's the reason we call it as advance. So this is the way how, an example, how the delayed and advanced version of the signals can be drawn. So similarly, if I try to sketch second example, if I try to ask you example for example 2, let us take x of t as a signal, which is a rectangular signal. I want minus t by 2, 0, plus t by 2, and this is t, and I want to, this is a. Now I want to sketch, can you sketch x of t minus t by 2 for this? And similarly, x of t plus t by 2 for this. I want these two versions. So can you think of it, the way we try to understand these particular signals, similar way we need to sketch this particular signal. So this rectangular signal is given with the magnitude of a from minus t by 2 to plus t by t. I am asking it to sketch x of t minus 1. Delayed version, how much delay? T by 2 seconds. And advanced version, how much advance? T by 2 seconds. Can you think of it and try to sketch these two signals? Simple, just you stick to the fundamentals. This is important to sketch these particular signals. Minus delay, right shift, plus advance, left shift. So with that basic with the fundamentals, we can sketch this particular signal. Now cross check, I'll try to sketch this particular version. This is total time period is t. If you look at this total time period is t. T by 2 in the sense advanced by, it's like this signal has to be 0 and this becomes t, and this amplitude is a. This is delayed version, means we need to shift this particular signal by half. This minus 2 by 2 will become 0 and the 0 become t by 2 and t by 2 will become t by 2 plus t by 2 will becomes t. The same, without changing the pulse width, we have shifted this particular signal as this. Similarly, if I try to advance this particular signal, we need to shift the signal towards left side by an amount of t by 2. So in that case, it becomes, the signal looks like this is a and minus t and this is 0. This is the way how the time shifted and time shifted version, delayed and advanced version of the signals can be sketched. We can do it for different examples. Just I have taken one example and asked you to sketch for the rectangular signal. Now coming to the time scaling operation. So what exactly mean by scaling? So if any signal is given x of at is the time scaled version of x of t, where a is the time scaling factor. So what is mean by time scaling exactly then? How do we sketch the time scaled versions of signals? Generally, if this particular the time scaling factor is greater than 1, the signal will be compressed. Signal is compressed. We call it as time compression. And if the time scaling factor is less than 1, the signal expanded. We call it as time expansion. Let us understand why this, if A is greater than 1, the signal is compressed, and why A is less than 1, signal is expanded, with a simple example. Now example for this, I am taking a signal x of t. Which is from -2, 0, +2. Let us consider this an amplitude is 1 and this is t. Now if I want to sketch x of t by x of 2t, how do I sketch? So when I say x of 2t, at, if we compare this 2t with x of at, time scaling factor a is equal to 2, which is nothing but greater than 1. If it is greater than 1, the signal will be compressed, time compressed. So what you do is just this limits, lower limits and upper limits will be divided by this particular rate. Irrespective of this value, whether it is greater than 1, less than 1, whatever it is there, just try to divide that the lower limits and upper limit, but by this particular time scaling factor. So if I try to divide this -2 with the time scaling factor 2, -2 divided by 2 will becomes 1, -1. Similarly, 2 by 2 will becomes +1. So this is the signal. Now this is 1. Now if you look at this, the total pulse width of this rectangular signal is 4, -2 to 0 is 2, 0 to 2 is 2. And whereas here this total pulse width of this signal is 2, the signal has been compressed in the time domain. That's the reason if A is greater than 1, the signal is compressed. That is called as time compression. Similarly, if I want to draw x of t by 2, how do I sketch? This is t. Now already I told you this a is equal to, here it is 1 by 2, because this can be written as x of 1 by 2 into t. So a is equal to 1 by 2, which is nothing but less than 1. So less than 1, what happens if time scaling factor is less than 1? The signal will be expanded. In the sense, simply just this lower limits and upper limits will be just divided by -2 divided by half will becomes -4, and 2 divided by 1 by 2 will becomes 4. So this will be the lower limits and upper limits for the resultant signal. So whatever these lower limits and upper limits are there, just try to divide them with the time scaling factor, and this will be the new limits, lower limits and upper limits for the signal. Now if I look at this, this is -4, 0, +4. The amplitude without changing the amplitude. So if you look at this, pulse width will be 8. So this is the way how the x of t by 2 is sketched. Now initially this pulse width of this particular signal is 4, now it became 8. The signal has been expanded. In the time domain. That's the reason we call it as time expansion. this is the way how the operations and independent variables can be understood, and even this is what we try to understand its single operation. Even we can also focus on the signals, how to sketch x of wherever the signals involves multiple operations, shifting and scaling, those signals also we can sketch with this fundamental knowledge. Thank you.